Welcome to G Fun Facts Online. Think of the Earth as a perfectly balanced spinning top. For billions of years, it has spun on its axis with a steady, predictable rhythm. But what if I told you that our own activities, specifically the massive global project of building dams, have introduced a subtle yet measurable wobble to our planet's rotation? It sounds like something straight out of science fiction, but it is a confirmed scientific reality. The incredible weight of water stored in thousands of reservoirs across the globe has physically shifted the Earth's rotational poles, acting as a powerful testament to humanity's profound and often unforeseen impact on the planet's most fundamental systems. This phenomenon, which scientists call true polar wander, is the direct result of redistributing mass on a planetary scale. A recent landmark study has revealed that the construction of nearly 7,000 dams between 1835 and 2011 has collectively caused the Earth's poles to drift by approximately 1.1 meters, or about 3.7 feet. This seemingly small shift unveils a fascinating story about the interconnectedness of water, geology, and the long-term consequences of our own engineering. To understand how a dam can move a planet, we first have to understand something called the global water budget. This isn't about money. It's about the continuous circulation of water throughout the Earth's system. It's the complex cycle of evaporation, condensation, precipitation, and runoff that sustains all life. Water is in constant motion, flowing from land to sea, cycling through the atmosphere, and being stored in various places like oceans, ice sheets, and underground aquifers. The distribution of all this water across the planet is a key factor in determining the Earth's overall mass distribution. The best analogy is to imagine you're balancing a spinning basketball on your finger. It spins smoothly. But if you were to add a small lump of clay to one side, it would immediately start to wobble and shift its balance. The Earth works in a similar way. Any significant relocation of mass on its surface alters its moment of inertia, which is just a scientific term for an object's resistance to changes in its rotation. Our planet's crust isn't perfectly rigid. It rests on a semi-molten, goopy mantle, which allows it to move and adjust to these changes in mass. When we move a massive amount of weight from one place to another, the crust wobbles, causing the geographic poles, the points where the planet's rotational axis intersects the surface, to trace a new path. This brings us to dams. For centuries, humanity has built dams for irrigation, flood control, and generating hydroelectric power. These structures are engineering marvels, but they work by impounding colossal amounts of water, creating vast artificial lakes where none existed before. The key point here is that the water held in these reservoirs is water that would have otherwise flowed naturally into the oceans. By trapping it on land, often in the planet's mid-latitudes, we are fundamentally altering the Earth's mass balance. We are taking weight that should be in the oceans and piling it up on the continents. A groundbreaking 2023 study published in the journal Geophysical Research Letters meticulously analyzed the impact of 6,862 dams built over nearly 2 centuries. The researchers calculated that together, these dams hold enough water to fill the Grand Canyon not once, but twice. This massive sequestration of fresh water on land not only contributed to a 21-millimeter drop in global sea levels over that period, but it also directly caused the observed polar drift. The study identified 2 distinct phases in this human-induced polar wander. The first phase took place from 1835 to 1954. During this period, extensive dam construction was concentrated in North America and Europe. This redistribution of water caused the North Pole to move about 20.5 centimeters, or 8 inches, toward the 103rd meridian east, a line that runs through Asia. Then, from 1954 to 2011, the second phase began. The focus of major dam building shifted to East Africa and Asia, with massive projects being undertaken in developing nations. This resulted in a much more pronounced shift of 57 centimeters, or 22 inches, toward the 117th meridian west, a line passing through western North America and the South Pacific. When you add it all up, the cumulative effect over the entire period was a polar movement of about 113 centimeters, or 3.7 feet, with the vast majority of that movement happening in the 20th century. Even a single, massive project can have a measurable, though minuscule, effect. China's Three Gorges Dam, for example, is one of the largest in the world. By holding back 39.3 billion cubic meters of water, scientists calculated that it alone slowed the Earth's rotation by a tiny 0.06 microseconds and contributed its own small push to the axis shift. Now, it's important to put this in a broader context. The polar wander caused by dams is just one piece of a much larger, more complex puzzle. The Earth's poles are not static. They naturally wander due to various geophysical processes. In fact, the most significant historical driver of polar drift is something called post-glacial rebound. This is the slow, ongoing response of the Earth's crust to the melting of the massive ice sheets that covered the continents during the last ice age over 10,000 years ago. As the incomprehensibly heavy ice melted, that weight was lifted from the land, and the crust is still slowly rebounding or rising back up, causing the poles to drift. However, in recent decades, human activities have become a dominant, and in some cases, the most powerful force driving this motion. Scientists have identified two other major man-made contributors that are working in concert with the effect of dams. The first is the melting of glaciers and ice sheets. As global temperatures rise due to climate change, glaciers in mountain ranges and the massive polar ice sheets in Greenland and Antarctica are melting at an accelerating rate. This meltwater flows into the oceans, redistributing an enormous mass of water from the poles and high-latitude land areas into the global ocean basin. This process has been directly linked to a sudden eastward acceleration of the axis drift that was observed starting in the mid-1990s. The second, and perhaps most surprising major human driver, is groundwater depletion. Humanity's thirst for water, especially for agriculture, has led us to pump vast quantities of groundwater from underground aquifers far faster than it can be naturally replenished. A stunning study revealed that between 1993 and 2010 alone, humans pumped out an estimated 2,150 gigatons of groundwater. That water doesn't just disappear. It's used to irrigate crops, it evaporates, and it eventually finds its way into the rivers and then the oceans. This redistribution of mass, from underground aquifers spread across the continents to the world's oceans, has been identified as the single largest climate-related driver of polar drift in recent years. This pumping caused the Earth to tilt nearly 80 centimeters, or 31.5 inches, to the east in that 17-year period alone. In fact, for years, scientific models of polar motion couldn't quite match the observed reality. They were always a little bit off. It was only when researchers finally factored in the effect of groundwater depletion that the models perfectly matched what we were seeing. So the big question is, should we be worried? Does a tilting planet have any real consequences for us? While the idea is certainly unsettling, the direct consequences of this polar drift on our daily lives are, for now, negligible. The shift is far too small to affect the seasons or change the length of a day in any way you would ever notice. For perspective, the planet's rotational pole normally wanders by several meters each and every year due to seasonal variations, like changes in atmospheric and oceanic mass, before returning to its mean position. The significance of this discovery lies not in some immediate, catastrophic impact, but in what it reveals about the sheer scale of human influence. It is a powerful indicator, a planetary scale signal of our collective actions. First, understanding the drivers of polar motion gives scientists an independent and powerful tool to verify and refine their climate models. By observing the poles wander and knowing what causes it, researchers can better understand continent-scale changes in water storage, which helps them calculate the rates of ice melt and groundwater depletion more accurately. Second, this research has direct implications for projecting future sea level rise. It highlights that the water we've impounded in dams has actually prevented a certain amount of sea level rise from occurring. This means that future models must accurately account for both the ongoing construction of new dams and the potential release of water from aging or decommissioned ones. But most importantly, the fact that our water management practices are physically moving the planet's axis serves as a stark geological wake-up call. It underscores the immense power we now wield and highlights the absolute necessity of sustainable practices. Scientists have noted that slowing the rate of groundwater depletion, for instance, could theoretically alter the course of polar drift, though it would require a massive, sustained global effort over decades. In conclusion, the silent, steady drift of the Earth's poles is a profound narrative being written by humanity. Every dam we construct, every aquifer we pump dry, every glacier that melts into the sea, adds another word to this ongoing story. While the wobble itself is gentle, the message it sends is powerful and clear. We are no longer passive inhabitants of this planet. We are active geological agents, capable of subtly but measurably reshaping the very spin of our world. This knowledge doesn't call for panic, but it does urge us to proceed with greater wisdom and foresight, recognizing that the delicate balance of our planet is far more interconnected with our actions than we ever imagined.